Well, we did our first equations on a tangent and secant line in part B. And we're starting part C with the definition that we used with finding the functional value of it and then dropping in the value. I don't drop in my values when I'm finding a tangent point. It's just additional math that confuses everything a little bit because the numbers all look different. So we're doing that. So now we're going to look at an example using a graph. In this graph, it says to estimate the slope. Now, on your in your textbook, I know that you can get pretty much an exact answer on this guy, and we're looking at the slope. So what we would do would be look at severe points of the line, and I have point there, but that doesn't work between them. And so let's see, what would I use here? I would use, well, I guess I would use, where's the first line here? On the red. Let me look. The red is right here and close to here. All right. So I have 2 points for this slope, and it would be up to over 1. So it's up to over 1. So the slope is 2. It would be difficult to anticipate the slope without kind of a positive movement, if you will, physically. And you can just do this any way you like. So here we have an example that we want to get to. And we're mentioning f prime because we want the derivative. Which is what I've been doing. I get the derivative first and then drop in the value. And here they mention f prime of x. We introduced this particular function, or I like dy dx, because that's a slope or tangent slope, and etc. But they're going to use f prime of x. And we want to find this and then find the value. So our first step is find derivative. Find f prime of x. So we're going to take the limit. Actually, I better write f prime. F prime of x equals the limit as x approaches, as h approaches 0, not x. Of, and I'm going to put the negative outside because the function is only on the x. So I'm going to have the x plus h squared plus 7 times x plus h minus 9 minus the original function. All divided by that h. All right, so I have f prime of x is the limit as h approaches 0, and we're going to do the math of FOIL, x squared plus 2xh plus h squared. A distributive property, 7x plus 7h minus the 9. Distributive property of a negative, plus an x squared minus a 7x plus the 9, all over the h. Now, we're going to do one more step to get this distributed. So here we go. We're going to take f of x equals the limit as h approaches 0 of negative x squared, negative 2xh, negative h squared. And then I'm going to have a positive 7x, positive 7h minus the 9 plus the x squared minus 7x plus the 9 all over that h. We're going to cancel out the additive inverses. All right, now I have h's left like we did. We've done it 100 times. So here we go. So we have f prime. Well, I got the red. Sorry, I got it. F prime of x equals the limit as h approaches 0, and I'm going to have the factor of h, negative 2x, negative h, positive 7, and that's it, all over h. We're going to cancel out h, and now we have, and take the limit. So f prime of x is the function negative 2x plus 7. Sorry, my computer is acting up. So now I did that. So our B is find f prime of 1. F prime of 1 equals a negative 2 times, my hand must be hitting something, plus 7. So my f prime of 1 is negative 2 plus 7. F prime of 1 is 5. All right, so I've got 5 for that guy. I'm going to do f prime of, we want 2. So I'm going to have a negative 2 times a 2 plus a 7. F prime of 2 then is negative 4 and 7. F prime of 2 is 3. All right, so the slope is 5, and now it's slowing down, right? It must be getting ready to change direction or something. And it's going to a 3, so let's do f prime of 3. And we can see that f prime of 3 is going to be a negative 6 and 7. So f prime of 3 is 1. Okay, so I end this section again using this rule. The derivative of a y equals some f of x of a function, and a is a number in the domain, then we should use the symbol f prime of a to denote the special limit. And so we have the f prime introduced. Sorry, the computer kind of phased out a little bit, but it's a good video. Thank you.